You want to get started, Sammy? I told you what is covered in your. Have you looked at the assignment or the practice test? Yeah, that will give you an idea what is covered. That will clearly give you an idea what is covered. Last class we were looking at Mason's rule. Formula for Mason's rule is G of S, which is equal to C of S over R of S, is summation over K Tk delta K over delta. We looked at the meaning of these terms. Right? What we'll do is we'll actually see how Mason's rule is implemented. Okay? Let's take a look at another example and see how Mason's rule is implemented. Alright, so this is your example, okay? So we'll take a look at step by step how this is implemented. So the first, step 1, is to identify forward path gains. Okay? So if you look at this, the forward path gains are what? You have, first one is G1, so I'll just skip the S part, okay? G2, G3, G4, G5, and G6. Okay. This is the only forward path. There is no other forward path, right? This is the only forward path. There is nothing going elsewhere. So, step 2. Forward path would be something which goes from this to this, from the input to output. So this will not qualify because you cannot come, it's a loop, right? Okay. So the second step is identify loop gains. So if you look at loop gains, the first is this, G2, H1, right? G2, H1, you have G4, V2, G4, H2, sorry. All right. And what do you have? G2, G3, G4, G5, and G6, G7, G8, right? That is also a loop gain. Or let's do this one first. You have G7 and H4. Okay, and then you have this. G2, G3, G4, G5. G6, G7, G8. Okay, so these are the loop gains. Step 3 is identify non-touching H3. Is there an H3? Yeah, there is no H3. It doesn't make a difference. It doesn't make such a big difference. You can call this H3. I'm just using something which is consistent with what the textbook. So this is example 5.7. The textbook page 252. All right. So you have forward path, you have loop gains. The next one is identifying non-touching loop gains. So if you just take these and see which are non-touching. Are these two non-touching? Taken two at a time first, okay? So here you can say A taken two at a time. So what is The first two are non-touching, right? So you have G2H1, G4H2. Okay. All you need to do is multiply those loop gains. That's it. So identify non-touching loop gains, taken two at a time. Are these two non-touching? Yes, they are non-touching, right? G2H1 and G7H4. Okay. Are these two non-touching? They touch, right? Now we'll do these two. These two are non-touching, right? G4H2 and G7H4. G4H2, G7H4. Are these two non-touching? They are not, right? G4H2 and G2, this one. They're touching. So that's out. Now the next combination is to see if these two are non-touching, which is again they are not non-touching, they are touching. Okay. So that is your taken two at a time. The next one would be taken three at a time. Right? So if you take these three, 1, 2, 3, they're actually non-touching, right? So if you can say G2H1, G4H2, and G7H4. You actually have one combination where they are where taken three at a time and they are not touching. Okay. Are these three not touching? They touch. Anything which involves this cannot be a non-touching loop, right? So the only possibility is these three. So that is taken three at a time. Step 4. You just start using the formula. So if you expand, see this one for example 5.7, you need to know how to expand this, okay? So you have this. How many, this K is what? The number of forward loops or forward path gains, forward paths. How many forward paths are there? How many forward paths are there? Just one. This is the forward path. Okay. So this thing would just be T1 delta 1 over delta. Okay. So what do you need to calculate here? You need to calculate T1, delta 1 and delta. So step 4, you start with T1. T1 is simply this. All right. T1 is G1, G2, G3, G4, and G5. Delta 1 is what? 1 minus, what did we say? 1 minus, or let's do delta first. I think delta is important. We can do delta 1 once we do delta. So delta is 1 minus summation of loop gains. So you just add all of this, okay? So you have G2H1 plus G4H2 plus G7H4 plus G2, G3, G4, G5, G6, G7, G8. 7, 8. Okay. So you have these plus summation of loop gains taken two at a time, right? That's what we said. So you have G2, H1, G4, H2 plus G2, H1, G7, H4 plus G4, H2 minus this G2, H1, H2. Okay. And finally, your delta 1 is, it is delta minus there is no H3, it's just H4. It doesn't matter. It's just a notation. I'm just trying to be consistent with textbook. Okay. Huh? Yeah, G7H4. So the So what you do is delta is 1 minus summation of these, summation of loop gain, plus summation of non-touching loops taken two at a time, minus summation of non-touching loops taken three at a time, plus summation of non-touching loops taken four at a time. So we don't have any taken four at a time. Right? Because if you take four at a time, you see they are touching. Right? So you don't have those. So that is where delta ends. Now what you do, your delta 1 is essentially, you look at the forward path, okay? We have just one forward path, right? If you look at the forward path and eliminate all the loop gains that are, so it's delta minus summation of loop gains that touch gate forward path. Okay. So this is, it's actually easy, but you need to pay a little bit of attention over here. See, the way you form delta 1 is, you take a look at what delta is, and you take a look at what the loop gains are. These are your loop gains, correct? How many of these are in the forward path K? Forward path. How many of these are touching the forward path? Not all of them. This is touching. This is touching. This one is not touching the forward path. This one is touching the forward path. So you eliminate all the gains which are touching the forward path. So if you take a look at this, delta is delta minus. If you look at this, this gets eliminated, right? This gets eliminated. This does not get eliminated. And this gets eliminated. So you have 1 minus G7H4. Okay. So let's look at this. Again, this gets eliminated because there's a G2H1. This gets eliminated because there's a G2H1. This gets eliminated because there's a G4H2. Similarly, this gets eliminated because there's a G2H1. If there is anything which is touching the forward path in this, that term gets eliminated. And you just end up with this. Okay. So now if you substitute this, so if you substitute this, so we're going to do step 5 here. You have G of S is equal to G1, G2, G3, G4, G5, G6 into 1 minus G7H4 over delta. Okay. So you have to write down all that delta. So this is your transfer. Let's take a look at this. Completes your chapter. I think we'll end it here, and we'll just do this. Chapter 5 is sufficient for now. So let's discuss a little bit about your midterm. Okay. I have sent you an assignment which captures what the midterm is going to be. You're done with this? I'm going to erase this part. Are you done with this? Yes, sir. That is the simplified version. Yeah. Mm-hmm. All right, that's your assignment. If you look at the textbook, chapter 3 is about state space representation. Okay. This is actually chapter 5. There's a typo. I'll change that. You will be allowed a formula note card. Okay. So you can note down, especially for chapter 4, the various formulas. You can note them down on a A2 size card. Okay. Use of cell phones, tablets will not be permitted. You will need a calculator. You better get your own calculator. Okay. Of course, all the other things are standard. All these things are really easy. Okay. If you know what you're doing, it is very fundamental, very basic. And if you need help, if you've already started, you might have questions, you can stop by my office. This assignment will be due on Friday. You don't have to submit it before the exam, but I would strongly encourage you all to do it before the exam. Okay. This is chapter 5. There's a typo there. Has anybody started doing the assignment? You have to just ask somebody to forward you the material, huh? Or you have to remind me. Mm-hmm. Yep. It's in your syllabus. Whatever you guys agreed to. Review your test. No, I don't think it is. I don't think it is relevant anymore. No, let me take back my word. It is relevant for this. You will still have state space representation. Okay. As a consolation, what I'm going to do is, I'm not going to include anything which will involve Kirchhoff's current law. Okay. Partial fraction, you may have to do it, because you cannot just you cannot eliminate partial fractions, because that's how it's an integral part of this thing. I don't think you will need to do any partial fractions actually, except for some of the problems here. You will not be asked to do any partial fractions. But you cannot ignore partial fractions. Okay? Yeah, you can type your formula. So keep in mind this is A2, okay? You know A2, right? What is the A2 size? It's your card if you're trying to give a talk or something. It's your index card, yes. So that is an A2 card, okay? You cannot do a It's half of your A4. You can do a half of your A4. No derivations, again, no derivations, no solved problems in your formula card, okay? If you have solved formula cards, you will not receive any credit. All your formula sheets will have to be attached to your exams. And if I figure out that there is any derivations or any solutions out there, you will not receive any credit. And that's it. Okay. Any questions? This is your review day. Yeah, but we're going to have a time to meet up again and go through any questions, or we're just going to go to your office? You can come to my office. I think that will be much more convenient if you attempt the problems. See, me solving the problems will not help unless you do it yourself. If I keep doing it myself again and again, you just sitting here and looking at it will not help you. Okay? You have to attempt it. You have to take out your pen and paper and attempt it. And chapter 5, this will not be a part of midterm. Mason's rule, signal flow graphs will not be part of but block diagram reduction will be. Okay. Signal flow graphs will not be a part of the exam. Block diagram reduction will be. Okay. That is what the reason I gave you this is, if you do this, you'll be prepared for the exam. If you do all of this, you'll be prepared for the exam. Okay.